Okay, let's go over the answers to the 9-1 homework. 18 was an isosceles right triangle. 19 was an isosceles triangle, but it was not right. 20, it was just a parallelogram, no specific name. 21 was a kite. 22, area was 5. Perimeter is about 10.8. It's okay if you left it in radical form. 23, area was 15, and perimeter was 16.3. Again, radical form is fine. All right, now let's go over the answers. On 18, you are looking at triangle ABC. So the first thing you want to do is check the lengths of the sides. So I need to figure out AB, BC, and AC. And since I'm going to use the distance formula, I'm going to go ahead and write down those coordinates. So A is a -2, 3. B is a +1, 4. And C is a 2, 1. Okay, so on this one, I'm going to do -2 subtract 1 squared, and then 3 minus 4 squared. So this is going to be a -3 squared, or a 9, and a -1 squared. -1 times -1 is just 1. So you end up with a square root of 10. For BC, you're going to have a 2 minus 1 squared and a 1 minus 4 squared. You may do 1 minus 2 as long as you do 4 minus 1. So this is a 1 squared, or 1, and a -3 squared, or 9. So this one's also radical 10. So now I know it's either going to be isosceles or equilateral. Checking AC, 2 minus -2 squared, and then 1 minus 3 squared. This is a 16 plus a 4 square root of 20. So the two equal sides shows that it is isosceles. Now, for a right triangle, I could check for a right angle, or I could just simply do Pythagorean theorem. A squared plus B squared has to equal C squared. So when I check Pythagorean theorem, I get 10 plus 10 equals 20. Therefore, it is also a right triangle. Question 19 is very similar. In this case, you're looking at triangle ADC. So I already know the coordinates of A and C from the problem we just did. And if I grab the coordinates of D, it is a -2, -2. All right, the three sides of the triangle are AC, which I figured out in the previous problem was radical 20, AD, which I'll need to figure out, and let's see, CD, which I'll need to figure out. So from A to D, I'm going to do a -2 subtract a -2 squared, and then a 3 subtract a -2 squared. Be real careful with your signs. This turns into 0 squared, and this turns into 5 squared. So you have the square root of 25. Okay. From C to D, 2 minus -2 squared, and 1 minus -2 squared. This is a 4 squared, and this is a 3 squared. Also the square root of 25. So these two equal sides make it isosceles. Now, to check to see if it's a right triangle, for Pythagorean theorem, 5 squared plus 5 squared should equal the square root of 20 squared. And actually, the longest, I can tell you right now, it's not going to be a right triangle. This is actually incorrect because the square root of 25 is the longer side. So you would have that the square root of 25 squared, in other words, 5 squared, plus the square root of 20 squared has to equal 5 squared. And there's no way that can happen. So it is not a right triangle. It's just simply isosceles. All right, for question 20, this time we're looking at a parallelogram, A, C, E, D. Now it tells me it's a parallelogram. So my mission is just to make sure that it is not a rectangle or a square or a rhombus or anything like that. So the first thing I can do is definitely notice that the angles are not right angles. You can definitely see that the slope here, which is undefined, it doesn't equal this slope. Okay, so I know right now it is not going to be a rectangle and it's not going to be a square. Now, in order to be a rhombus, I would have to have 4 equal sides. So I could just pick 2 that were consecutive, like AC and AD, and see if they were equal. Then I would know maybe it would be a rhombus. Now, we've already figured out AC up here in problem 18, and AD right here in problem 19. So these are not equal. So it is not a rhombus, it is not a square, it is not a rectangle, it is only a parallelogram. Give you a minute to look at that one. I realized that was off the screen. All right, question 21, you're looking at A, B, C, D. Now, taking a quick glance at A, B, C, D, gosh, hopefully you can tell right away that it is not going to be a parallelogram. Your opposite sides aren't congruent, at least not visually. It would be a trapezoid if you had a pair of parallel sides. And you can do a quick check on the slope of 3/4 and 1/3 and see that it is not a parallelogram. So your only option is that perhaps it's a kite, and it sure does look like one. I need to see if A, B, and BC are the same, and if AD and CD are the same. AB, we figured out from problem 18, was the square root of 20. BC, we figured out, oh, I'm sorry, I'm wrong. AB, right up here, is the square root of 10. BC is also the square root of 10. So those sides check out. Now I have to check AD and CD. And AD up here was a 5, and CD was also a 5. That checks out. So you have these consecutive sides are the same, and these are the same, making it a kite. Okay. 22, you're looking back up at A, B, C from problem 18. And for the perimeter, you're going to add up all the sides. So the square root of 10 plus the square root of 10 plus the square root of 20. So if you go back to my answers, you have 2 square roots of 10, and then the square root of 20 reduces down to 2 radical 5. Or you could put all this into the calculator and you get approximately 10.8. Now, for the area, it's base times height divided by 2. Well, we determined it was a right triangle. So that would make base and height these two. So the area is going to be the base times the height divided by 2. So that would be the square root of 10 times the square root of 10 divided by 2. That's the square root of 100, or just 10, divided by 2, or 5. If you did 18 and 19 right, the rest of this is just pretty easy because it's all using that information. Okay, for the last one, you're going to do the area and the perimeter of A, B, C, D. So for the perimeter, you need A, B, and B, C, which are both radical 10s. and you need AD and CD, which are both 5. 2. And you do get an area of 15. Okay, this wasn't a hard assignment, but it did have some tricks in it, so go back and re-watch the video for anything that you're still confused about.